So I'm not sure. I think that on the schedule it said comprehensive wireless LAN testing, but it's really performance testing that we're going to be focusing on. And to get started, I just want to do a quick poll to try to find out what kind of testing experience we have in the audience, and then also give me an idea of what I can spend more time on. So first of all, single AP performance testing, and not just not just a client throughput, but more like a formal plan where you had a series of test cases, maybe some voice, some video, maybe a combination of voice, video, and data. Can I see a show of hands? Okay. All right. How about for multi-AP? Same kind of thing. And how about multi-AP including roaming tests, voice roaming? So good. So it's all very relevant. So one more. How about in competitive bake-offs? Anybody? Yeah. Okay. Good. Good stuff. All right. So a little bit about me. I've spent a lot of time doing performance testing. Years ago in an RF chamber, 2.4, locked away for, it seems like days on end. But now that it's more of a 5 gig world, where's Devin? Yeah, more of a 5 gig world. I've been let out of the chamber, and I spent a lot of time in a 20,000 square foot carpeted facility that was dedicated for performance testing and did a lot of competitive performance testing, everything you can think of pretty much. And that's may sometimes be bad. We'll see. Time will tell with all that radiation. All right. So the process. Just a little bit about the process. If you, well, for me, anyways, it's all about trying to determine if a use case is going to work for the customer. I was out in the field for many, many years, and to me, is the network going to work? Are all devices, all applications, going to work everywhere throughout the whole network all the time? So really trying to really nail down the use case and then trying your best to model that use case. And sometimes it's really not possible because modeling the environment is probably the hardest thing, but at least trying to determine what the use case is and then going for it. There's obviously different types of testing. QA testing may use VeriWave more than, like, for instance, the type of testing I do where I'll use Chariot and I'll use other things like iPerf. And then you also you have to get the right kind of clients, right? So if you're going to be if you're a customer, they're going to see mostly 2-stream clients or single-stream clients, then you want to use those type of clients when you're doing the testing. So just making sure you model as closely as you can to what the use case is going to be. All right, so just quickly about some use cases. So for high density lecture hall, that would be maybe categorized as like a high density, maybe moderate throughput or high throughput. It depends on what the application is. So that type of use case, it was something that I could model in the facility that I was in. Hotel room, guest room, you'll have voice, video, data, but it wouldn't be very high throughput because we know that the pipes going out to the internet where all the services are, and most likely they're not going to have video services local, at least not in the US. So you're going to, it wouldn't be a very high throughput, but just to make sure voice, video, and data work. And ICUs, how many have done any kind of testing or work with ICUs? I'm sure it's heard. So they can be high density because you can have a lot of devices connected to a single patient, infusion pumps and monitoring and so on. So you can get pretty high density in those type of environments. Now, that type of test, you can't model exactly with the type of clients most of the time because then you'd have to, partner with you'd have to get the Hosperers and all the other Welch Allens, all type of devices in, which is very often difficult. But for those type of scenarios, you may be able to get the environment from like where a hospital that will partner with you and put aside. They actually, for instance, Kaiser Permanente, they have a fake hospital nearby where you can do your testing. So you might be able to do that, for instance. Okay, for a lot of times you'll see for electronics, you'll see where they want to stream local content. So you can get very high density, high throughput type of environment with streaming video. And airport terminals, high density, maybe low throughput where all the clients are rate limited. All different types of devices. K through 12, video streaming, it's a big part of curriculum in a lot of schools. And that content can be fairly high quality, so might be not very high density, moderate density, but with high throughput per device. All right, so for tools for traffic simulation, we use JPerf. we'd like to use Chariot. I've been a big fan of Chariot for many years, moving to version 8 like Chuck suggested. But not everyone has Chariot out in the field. So for bake-off, sometimes if you're preparing your team for a bake-off, if you work for a vendor or you work for a VAR and you're preparing your team for a bake-off, you may actually have to do the testing with iPerf if that's all they have, or Temasoft throughput test. Exia VeriWave, that's more, we see QA using that more. I've seen it in bake-offs, but it's really rare that you see that in bake-offs, probably because it's a more expensive tool. And for monitoring and analysis, these are the tools that I would have open pretty much all the time while I'm doing the testing, because most of the testing I've done in the last several years has been open air. So you have to watch those channels like a hawk, because the building that we had for doing the testing in the past was far enough away from neighboring buildings so that you didn't have to worry about it too much. But most of the time, you're not going to have that luxury. So if you have a channel or 2 channels or whatever set aside for your performance testing, you kind of have to watch those channels all the time. And if someone jumps on those channels, or if there's non-Wi-Fi interference on those channels, it would invalidate your results. So we'd watch those very carefully. As far as clients, Chuck, that's a great lab. I'm envious. Yeah. So, but we try to build out the lab as much as we can with a diverse set of clients, again, to model what our customers would be using. And I put PlayStation there because actually in higher ed, anyone in higher ed, you got to get those PlayStations working right in the dormitories. So we'd have some of those. We'd have all kinds of devices, all different manufacturers. So there's a little QA happening here. When you have a mix of clients, there's not just performance testing, but then a little bit of QA happens as well, unfortunately. All right, for the applications, there's so many that you would use, but again, we try to use the applications that the customer might use. So I don't have like VBrick here, but you might, if you're a university, you're working with the university and you want to do some testing, you might have some type of media streaming server. We would use Windows, we test with Link. FaceTime for doing video conferencing, and VLC is very popular. Everyone uses it. It's great for multicast, sourcing multicast or unicast over HTTP. We use Windows Media Streaming Server mainly for sourcing a unicast over RTP, for instance. Okay, this is an eye chart. I threw it up there, but this would be something that we'd put on the end of a report, like a presentation. We'd have a slide or 2 or 3 setting the parameters, so how we tested it, how many APs we used, how many channels we used, DFS, not DFS, what type of traffic, which application we used to source the traffic, and a little about the clients and so on. So that you'll have that if you want for reference, and more of the same. In this case, we said Skype was used for voice. We use FaceTime for video conferencing, and we had some for this particular. This is a multi-AP test, and we would do the roaming with FaceTime. How many at universities will you see students actually walking around with like FaceTime or Skype and video conferencing? Because I've asked this question before, and it's a real use case. I find it hard, but people are video conferencing and walking around. So so we had to test it. So now here's an example of but just 8 test cases for a multi-AP test. So start with low density just to get an idea of the capacity. So you wouldn't have very many clients per radio in that case. You're really not you're not factoring in contention. You're just trying to see what the the throughput you can get without those externalities. Then you would go to high density where you have a lot of contention. And in this particular test, well, let's say we had a 20,000 square foot facility and we didn't have DFS channels. We'd have to reuse channels. If we use wider channels, we'd have to reuse channels. So you'd have contention, co-channel interference to deal with, and potentially adjacent channel interference. And so we could see the impact of that type of network. Otherwise, we could have DFS channels and not have to reuse channels at all, and then we would not have to worry about co-channel interference. So I have data downstream and upstream. We used to have use like a 9-to-1 ratio, but as applications change with more social media, that ratio has changed. So you'll see in this example test template I have that it's more like I think I'd have 7-to-3. So, and I've seen some reports where it's like arenas where it's actually I think it was in the World Cup was like something like 4 up to 6 down or something like that. It was the upstream, so upstream is growing, so you want to model those patterns. And then you have some other ones here where you have a combination of voice or video and data. And probably the one that is going to be the most challenging is really the last one, voice, video conference, and data upstream and data downstream. So that's challenging. And if you do this type of testing, especially in a multi-IP environment where you have to reuse your channels, you see how things break down pretty quickly. And it's pretty eye-opening. That's an example set of test cases. Let me move on to a workbook. We don't always have a chance to put together a formal written test plan. A lot of times, you hear about a bake-off, and you're going to have these test cases. You've seen the bake-off test plan anyways, so you just put together a spreadsheet to get that data. And if you're using Chariot for a lot of the throughput tests, if you can create I'm going to make this fit a little better. It's probably very hard to see. Let me see if I have I don't have a pointer, but I'll just step out here. So anyways, you're able to, if you're using Chariot, for instance, you can get that, save it as a CSV, and then just cut and paste it and throw it in here, and then sort. And what we do here, this is a very useful thing to do if you're trying to see if your clients are going to meet an SLA. You actually take them, and then you can sort them from best performer to worst performer. In this case, we have single stream 11N clients. It's hard to read, but those are iPad minis, 2 spatial stream MacBook Airs, and then some MacBook Pros. And we sort for each individual type of client, worst to best, and then we plot it. And so you can see that the red line, it looks like pretty much, on average, each type of client's getting about the same amount of throughput. But then the blue line represents, as you have these lesser capable clients, you're going to see less throughput. And then the dual spatial streams, you'll get more throughput, and then the 3 spatial streams, you'll get even more. And so this would be indicating from, I'd look at that and I'd say, well, AP vendor A is doing airtime fairness, whereas AP vendor B is not doing airtime fairness because you don't see the benefits of having a faster PHY rate. So anyways, if you sort the traffic like that, there's a couple of things you can reveal. And there are lots of other, actually I have lots of other sheets in here where it's ready-made, so you just do the test, you throw it in there, and then you can get your graphs and you can do your reports and present your data. So it kind of speeds things up. And I can make that available to that spreadsheet. Okay, so that's pretty much it. Thanks for the time, and I'd like to continue the discussion. Thanks.
Thank you.